I know that in traditional, what we would call predictive machine learning, um, I remember when I was a little bit younger, there was a lot. I mean, we still talk about this, but back then, even more, we talked about like making the models explainable, right? And trying to understand like what is driving the prediction. And I don't know if you could maybe share a few thoughts on how the solution to this is causal, right? And maybe that we can get the answer like that.
Yes, so this is very interesting. It's again, it's a very hot topic, and basically, it's exactly what I teach in my class, from prediction to causation. It's an online class, mainly for ML experts. And basically, here I mentioned also in the book there is one full chapter dedicated to this difference between predictive inference and causal inference. The thing is, when you do predictive inference, you exploit correlations again, and a strong predictor is not necessarily a cause. If you can explain the model, so you have two things also depending on the audience. You have things that are interpretable. An interpretable model is one you can directly look at the coefficients, for example, a ridge regression, and you can interpret directly the results to understand what is driving the prediction directly without additional steps. If you have more complex models, like deep learning models with thousands of parameters, eventually, it's very hard to interpret these parameters with several layers. So here you need some additional tool allowing you to explain the coefficient and understand what is driving the prediction. The thing is, it's still predictive inference, and the features that drives the prediction are correlational. And you can have very strong predictive power while it's not necessarily a cause. And I show this in the class. I could show code here and simulation, but maybe I'll keep this for another day. I'll share it otherwise. But I show this very precisely with within my class. I show that basically you have your correct causal model, allowing you to predict an effect. And then I include what we call a collider, which is basically a consequence from from the cause of interest and the outcome of interest. And you include this in the model, and this completely messes up the estimation. All the coefficients are completely biased. And most importantly, you can see that one of the main driver is the collider. And the collider is, again, it's not the cause, it's a consequence from the others. So and from a predictive inference perspective, this last model, when you include the collider, in my example with simulated data, it's the one with the highest predictive power. And the collider is the strongest predictor. But from a causal inference perspective, even if you have a very high predictive power and this feature is a very strong predictor, highly statistically significant, it's completely wrong from a causal inference perspective. And that's usually one of the things that is shocking. So back to your question, to conclude again on what you ask, making a model explainable or interpreting the result of a predictive inference model still do not mean that it's causal and that you can interpret the coefficient as causal.